Alright, so here we are. We have an integration problem. It is the fraction 6 over the quantity 9t squared plus 1, all that squared, integrated in terms of t. So we're going to try this using a trig substitution. It is two squares added together, the 9t squared plus 1. So that's the type we're going to use. Okay, so let's just kind of identify the parts that we've got here. It looks like we're going to have, as far as the variable part, 3t is going to be the part that represents our x, and 1 is going to be the part that represents our a. Okay, when we compare that to our template. Okay, so our type. So let's see, if we have that information, let's just be very careful here. So what we have is we know that the square root of a squared, which is 1, plus x squared, which will be 9t squared, will be the secant of theta. Now what we have in our problem is not a square root. What we actually have is the thing squared. So how would we get there? We could square both sides of this and get 1 plus 9t squared equals secant squared. So maybe we'll just stop there and kind of figure it out in a moment. So then the other thing we need is the dt. So in this case, our dt will be, it looks like secant squared theta d theta. Okay. And let's draw our, well, let's do another color here. We'll use green. Show where it comes from. We don't have a T we need to replace specifically. So let's draw our little triangle. So in this case, our A, which is our adjacent side, is 1. Our opposite side, which is our x, is 3t. And our hypotenuse is 1 plus 9t squared and the square root of all that. Okay. Got a little bit of lag going on with the computer right now. So let's make a couple of substitutions here. So we got that 6 up top. Let's just pull it out front. So we'll have 6 in the integration of, we'll put 1 on top. On the bottom we got 9t squared plus 1, which we're calling secant squared, but that is a quantity squared. So we'll make that secant to the 4th theta, and then the dt will be secant squared theta d theta. So I have a secant squared on top and a secant to the 4th on bottom. So if I clean that up, I'll have a secant squared on bottom. Let me do this. We'll have 6 integration of 1 over secant squared on bottom. But secant squared on the bottom comes up as dun, 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 cosine squared. Okay, so we got 6 times the integration of cosine squared. I'm trying to erase something here. Let's see if it catches up with me. Yeah, I just didn't like the way my 6 looked there. So, how do we integrate cosine squared? Well, we come back and we remember an old formula. Cosine squared of theta is 1/2 plus 1/2 cosine of 2 theta. Remember, we can reduce the power, but we increase the angle. So we'll use that. So we'll have 6 integration of 1/2 plus 1/2 cosine of 2 theta d theta. Just kind of pushing through that, we'll have a 6 out front. The integration of 1/2 in terms of theta is 1/2 theta. And the integration of 1/2 cosine of 2 theta involves a u substitution, which takes you back to the integral of 1/4 sine of 2 theta. So we have that. Okay. So let's see here. Well, there's a plus c too. So let's go one more step, or a couple more steps. Let's clean up this part first of all. 6 times 1/2 will give us 3 theta. And then 6 times 1/4 will give me plus 3/2. But our triangle is not going to deal with the angle 2 theta. So let's change that using sine of 2 theta equals 2 sine theta cosine theta. Use that trig identity. So we'll change sine of 2 theta to 2 sine theta cosine theta plus c. So I think we're at a point where we can go ahead and we can go back to t. So 3 theta, looking at our triangle, 3, and it looks like we could use the inverse tangent because that would be opposite over adjacent, so it would be the inverse tangent of 3t. And then plus, we got 3/2 times 2, which will just be 3. And then we need sine times cosine. Sine is opposite over hypotenuse, so that's 3t over the square root of 1 plus 9t squared times the cosine, which is adjacent, which is 1 over the square root of 1 plus 9t squared plus c at the end. One last thing, because I think we can clean up a little bit more. The first part is going to stay the same, so 3 tangent inverse of 3t plus 9t over the 2 square roots will knock each other out, so it'll be 1 plus 9t squared plus c. Okay. So there is our answer if everything went right.